QCon AI, the Practical ML conference for software engineers, returns to San Francisco April 15th through 17th. Discover emerging AI trends, essential tools, and how to apply AI in your software projects. Save $80 using the code InfoQ19. Find out more at qcon.ai.
This past November at QCon San Francisco, I got the opportunity to introduce someone who, through his talks, writing, and community contributions, has directly shaped not only my own personal career in software, but software in general. His over 40-year history in software means he's not only been at ground zero for movements in software from design patterns to OOP, but the recent interest and spike with AI. As any software developer knows, he's also had to rebuild himself many times over as technologies continue to evolve over the years. My name is Wes Reisz, the host of the InfoQ Podcast and chair of the QCon San Francisco Software Conference. Today on the podcast, I'm speaking with Grady Booch. Together with Ivar Jacobson and Jim Rumbaugh, Grady is recognized as one of the creators of UML. He was part of the community that drove and then matured the conversations around design patterns and has been prolific in evolving the discussions around OOP. Today, Grady is the chief scientist for software engineering at IBM Research, where he works in cognitive compute and is helping to shape the conversation today around machine learning and AI. Grady is a fellow for the ACM, IBM, IEEE, and has been recognized by the British Computer Society as a Lovelace Award winner. On today's podcast, we're going to follow up a bit on that keynote with some questions that have been burning on my mind since this past November. We're going to discuss a bit about AI realities and redefining the space, or at least defining the space today. We're going to talk about the history of AI and some of the past winners after them. We're going to talk a bit about architectural consideration as you're building platforms that leverage machine learning today and AI. We'll talk a bit about the road to artificial general intelligence, AGI. And then finally, we'll wrap with some tips and things to think about as you're developing applications today that may leverage the power of machine learning. As always, thank you for bringing us along on your runs, commutes, and jogs and gym time. Grady, thank you for joining us on the InfoQ Podcast.
Wes, thanks for having me. I appreciate it.
So the talk that you did at QCon San Francisco, the keynote, was called Building the Enchanted Land. Why that title?
Alan Newell is one of the founders of AI, and together with Herbert Simon, they pioneered the symbolic approaches to AI. I think it was in the 50s, Alan wrote this fantastic article called Fairyland, I think is the title. And in it, he was projecting ahead the next several decades in which he predicted the rise of computers and their pervasiveness throughout the land. And had this delightful phrase in which he said that with the rise of computation, with the ambient computing he expected to come about in the world, we had the ability to produce an enchanted land. So that's what I referred to. To update the phrase, I use the following concept, which is software really is a remarkable kind of thing. And it's the hidden language that speaks the stories of possibility to our hardware. And software developers, systems developers are the storytellers. So we are the ones who are building that enchanted land.
I remember specifically the closing. It was a very clean closing with that. I thought it was phenomenal. So as we were discussing this keynote, one of the things that we talked about was really kind of dispelling some of the FUD, the fear, uncertainty, and doubt around AI for software developers. So it's pretty safe to say, I think, that you don't subscribe to the mindset that AI is going to be replacing the software engineering anytime soon?
Not anytime soon, although you subtly changed the topic in a way, not to berate you, but I think it was fascinating to say there's the fear of AGI in general, but then let's look at what that might mean for the software developer in particular. They're related but subtly different topics. At the one end, there really is a fear in the general public for AGI and AI in general, largely because it's been in the media, it's part of our mythology. We see the Terminator and HAL and Alexa, hang on, I need to shut up Alexa because she thought I was flirting with her. There we go. I don't want to order something here accidentally. And so this notion of having a pervasive AI around us has been in media, and there is tremendous fear. I did a TED talk on it because, frankly, Elon Musk and others love the guy dearly, but he's been doing some fear mongering, and I think that's wrong. Now, to talk about your subtle topic, which is a very important one, what does AI mean for the software developer? That's really a fascinating one because it's an evolving topic, and I think one can break it apart in two ways. The first is from a system and software development perspective, what does it mean to build systems that have AI components? That's one topic. And the second is, what can AI mean for me? Might AI actually change the way I build systems? Might I see AIs that help me debug and help me test or even serve as pair programmers for me? And the answer in the latter one is yes, that we're beginning to see AI play a role in the software development process itself. And frankly, that's very exciting.
So, okay, there's distinctions there. There's a general purpose AI, AGI, and there's AI.
Yes.
So we definitely are seeing tools today that are using machine learning to be able to help us do things like discover code, things along those lines,
Yes.
do better performance in code.
Yes.
But break this down. What does it mean for like an AGI when you talk about HAL and Terminator and those things?
Great.
How far are we between AI and AGI?
There's a really interesting spectrum I think one can consider. In fact, the problem with AI in general is that we keep moving the goalposts, that what we called leading AI in 50s, 60s, 70s, all the times we had the various seasons of AI, today we would call it, oh, that's just, real interesting algorithmic analytics. So the bar keeps changing. I dare say that a decade or so from now, the wonderful things happening in deep learning, people will say, oh, well, that's just, some interesting gradient descent things. That's not AI itself. So the bar keeps moving, which is actually good, keeps us on our toes. Let me give you my definition of what AI is, because to know what it's not is also important. I think there's a litmus test for AI that represents a system that learns and that reasons. Now, Hinton pointed out in a recent lecture that if you look back at the symbolic AI folks of the 60s, 70s, 80s, and beyond, their focus was upon reasoning, that they viewed reasoning as the definition of what intelligence was. And that's reasonable, not to make a pun, but the ability to do chess, to play Go, to manipulate blocks, to converse in the world, those are all elements that require reasoning, and that's reasonable intelligence. The deep learning community, I think, emphasizes the notion of learning, that an AI system is one that learns over time. It may be supervised or unsupervised. But for me, both of those things fit together, that if the system does not learn and does not reason, that it's not AI, it's something else. And frankly, a lot of things, fall by the wayside. I see far too many systems and individuals who say, oh, yes, I'm doing AI, but it doesn't have both of those components. So buyer beware. When I moved to AGI, this is another ball of wax entirely. I had the delightful opportunity to do a video recording with the actor behind C3PO. And he asked me the question, when is AGI going to happen? It's going to be happening in my lifetime. And my answer was, no, this is a multi-generational thing. That very likely we will not see AGI. I do believe AGI is possible because I'm a pragmatist, a materialist, if you will, that I think the mind itself is computable, so it's inevitable. But we're a long way away from it because AGI requires degrees of common sense. It requires not just inference and not just deductive and inductive reasoning, but it also requires abductive reasoning, the ability to build models of the world, models of the self, models of others, and actually manipulate and reason about those without acting on the world itself. And we're a long way from doing any kind of general model building or abductive reasoning or common sense reasoning. So that's why I'd say it's a generational problem. It's inevitable. I think it'll happen someday, but not in my lifetime and probably not in the lifetime of your children, your children's children.
So you see it more as AI today is kind of augmenting, helping, assisting, kind of human in the loop, not necessarily replacing the human in the loop.
Well, in fact, I think AI in general should be something that helps augment the human body and the human mind. That's the role it can and should play, and it's already playing. A lot of what's happening in contemporary AI is what I'd call sensory AI, using deep learning to look at streams of data, images, videos, voice, and then detect patterns in them. So a lot of it has to do with pattern classification. Now, I'm going to go a little bit deep here, but if you think about it, symbolic approaches to computation, which we've been doing for decades, and deep learning approaches, which are based upon models of the mind through neurons, they're actually computationally equivalent. They're Turing equivalent, which means that I can do processing in one versus the other and get the same outcome. It just requires different amounts of space and time. What's great about deep learning and approaches that are inspired by how evolution has built intelligence is that it gives us some really convenient mathematical tools to do this kind of reasoning and learning. And its best successes have been in the area of pattern matching kinds of things, finding cats and dogs or melanoma in images, for example. That's where it shines.
The current kind of surge, I guess, around machine learning, AI today is kind of powered by deep learning. But this isn't the first time we've had kind of a cycle for AI. You actually already referenced it once. I think in the 50s, you talked a bit about how language was first used, like Russian to English was one of the first kind of use cases of AI. Can you go back and revisit kind of like some of the different stages and give us some context of the ups and downs and the winners that we've seen over the last 40 years?
With pleasure. I won't break into song from Rent, but there have been not many seasons of love, but many seasons of AI in my lifetime, and I expect there will be many more. Andrew Ng has done a delightful summary of this, and so I'll summarize his summary. But yes, the first period, the first season of AI was probably that of the 50s and 60s, and it's notable that that was the height of the Cold War. So a lot of things fueled some of the AI research. Quick aside, I'm doing a documentary work and talking about computing and how it impacts the human experience. And one of our theses is the notion that a lot of what happens in modern computing was born from warfare. It's a phrase I use, that we see computing as woven on the loom of sorrow. And that's very true of the early days of AI, that the fears of the Cold War funded a lot of some of the early AI research. But we quickly realized that language is just really messy and it's difficult, and one could not easily codify it. So funding kind of dried up. And it wasn't until the 60s and 70s we began to see a renaissance where the ideas of knowledge was important. So knowledge representation became critical. And this is where Ed Feigenbaum and others really began to play a role. Classic example of this is there was, I guess, Campbell Soup had a guy who was responsible for the final taste testing, and they knew he was going to retire. And so how do you capture his knowledge? So through a series of interviews, they were able to develop a number of rules about the taste tests that they were then to capture from the human. But the problem with rules, as Ed and others quickly learned, is that it doesn't scale very well. So much like the earliest days of AI, its funding collapsed as well too. And around that time as well, you had the whole ecosystem in Silicon Valley that was up and running, and it spawned a number of companies, Symbolics, Thinking Machines, and the like. And unfortunately, they kind of fell down that implosion as well. It really wasn't until recently where you saw the perfect storm of tremendous amounts of data, a la Facebook, Google, and Amazon and the like, together with the rise of GPUs, giving us tremendous computational power, together with the revival of some algorithms, gradient descent and the like, that had been invented in the 60s, 70s, and 80s. That perfect storm of those three coming together is what's enabled the current breakthroughs in deep learning. Will there be a winter? Well, I'm wearing a sweater now because even folks like Gary Marcus in particular have observed that there are limits to what we can do with the current models of deep learning. Even Gregory has observed this as well. Now, it's going to be a little bit different from the previous years because AI has proven itself to be valuable in so many economically interesting places. But I don't think it's going to be quite as big as what many had first hoped.
Deep learning is a panacea for a lot of people. It's AI, but the reality is it's good at some things, not a lot of things. What are some of the limits that are out there for deep learning?
There's this great commercial from Saturday Night Live a few years ago in which they were touting this wonderful product that was a dessert topping and a floor wax. The problem with deep learning is that it's not a dessert topping and a floor wax. There are some things it's very well suited for, which is pattern matching. There are some things it's not really very well suited for, and that's some of the model building and deep learning. There is an existence proof that deep learning in neural networks in particular can lead to some incredible amounts of reasoning and learning. And that example is you and I talking right now, because even though we're talking in symbols and reasoning in symbols, we're built upon a layer of neurons, a very, very complex set of them. So we know it's possible. But the question is, will we be able to build billions upon billions of neurons, to quote Carl Sagan, to build those kind of systems in the coming years? And the answer is no, we're a long way from it, because computationally it's incredibly hard to do so. So I expect that most of the deep learning that we'll see in the coming years will still be mostly predicated upon pattern matching kinds of things. And we probably need to have some breakthroughs in our understanding to build AIs that build models of the world. Let me talk about that a little bit more. When I think of models of the world, it's like when I'm walking, my brain is making models of the people that I see, the boats I see, the waves I see, and I can reason about those. It's easy to build an AI using neural techniques that are very Elijah-like, that it's kind of reactive. But to do that in neurons, to build those kinds of explicit systems, we haven't quite figured out the math for it. This goes back to Rodney Brooks's idea of intelligence without representation, that yes, we see things like slugs and other lowercase kind of animals that can move in the world, but they don't build these models with which they can manipulate. We haven't gotten there with deep learning, and I think we're a long way from it.
So there's a quote that you said before: the entire history of software engineering is in a rise in the levels of abstraction. How do you think the rise in levels of abstractions will be present with these tools of AI and how they're kind of affecting the art of software today?
You raised the issue of patterns, which I think is important. And as you pointed out at the beginning, I was involved in the patterns movement in its early days. The classic book, of course, is Design Patterns by Vlasides, Johnson, Helm, and Gamma. And in it, it makes the wonderful observation that the code is the truth, but it's not the whole truth. There are certain kinds of structures that transcend individual lines of code, that transcend classes themselves. The classic example is that of the model view controller pattern, which pervades most UI kind of systems. So even then, there was a recognition that there exist common patterns that transcend code. Well, if you think about it, deep learning is a lot about patterns. So the question is, could we use deep learning techniques to find those kind of patterns? And the answer is yes. People are starting to do that. It was probably Microsoft that pioneered this some years ago when they were doing automated testing for device drivers for Windows. And they recognized, wow, there are indeed some patterns of implementation and patterns of use that they could automate tests for against it. I wouldn't necessarily call it AI in its time, but it pointed to the direction of the things that can be done. So imagine now, from a software developer's perspective, having an AI look over your shoulder, figuratively, that would say, hey, you're doing this, and boy, it looks awfully familiar to this pattern. Why don't you try this? I hate to use the phrase, but it's kind of like an AI Clippy on steroids, but better than Clippy, of course. And that's where I'm seeing some people experimenting these days, trying to build AI assistants that help the software developer.
What are some of the use cases that you're seeing that are innovative AIs that are kind of affecting software, like such as the Clippy example?
Sure. Well, I'm seeing it in a couple of domains. The first is that of testing, where I've begun to see some AIs that begin to look at the code itself and actually can offer recommendations, if not create the code and test itself, for the edge cases where it says, hey, I think you might get in trouble here, so let's build a test against it. It looks for, simple things like Stack Overflow and the like, but it can actually go deeper. So that's one place. The other place I alluded to is actually looking at your source and making recommendations for simplification or the discovery of patterns among them. And that's where I'm seeing experiments taking place.
Yeah, so refactorings with an AI refactoring tool, for example.
Yes. Absolutely, yes. Martin Fowler has a second edition of his book. Love Martin, love his book. If you haven't gotten it already, rush out and buy his second edition now. But you can imagine an AI that's taught those refactoring patterns that could actually assist you. That's within the realm of possibility.
We talked about before the fear, uncertainty, and doubt. Does that mean software engineering is a dying discipline, that we have AIs that are going to be replacing us?
Oh, I think software engineering is a flourishing discipline and will continue so, because what those kinds of AIs will do for us is actually remove some of the tedium that we've had to do as humans ourselves, enabling us and freeing up our minds to go off and deal with the more complex things. Software development is complex and it's not going to change. People have long said, oh, we're going to have, software that writes software itself. Well, we already have that. We call them compilers. but by no means have we been able to build systems that do meaningful kind of design. We're a long way from it. Software development has been, is, and will remain a labor-intensive activity for decades to come.
It's a rising level of abstraction, right?
Exactly. Back in the COBOL days, people thought that, oh, with COBOL, now we can have non-programmers write down rules about business. Well, of course not, because it still requires you to express it in some very precise ways, and that's programming.
One of the things that you talked about in your keynote was that how machine learning and AI are going to be pieces of a larger software product that you put together. I'm curious on kind of what you meant by that.
If you look at every AI system that exists out there, from the AlphaGos to Cortana to Alexa to Siri, all of these things that are very visible in the public eye, turns out that AI is a piece of it, but it's a much larger system in which they're built. If I take Cortana, for example, or Siri, that's an easy one. Siri does have AI in it. There's natural language recognition, natural language understanding. Those are all very distinctly AI kinds of things. And there's some really cool Bayesian stuff going on where if I ask for something, it can kind of figure out what my intent is. And through some interesting learning that's gone on, it can give me a reasonable answer. Google does this as well with Translate by having billions upon billions of translation requests taking place. They've begun to discover, they have enough data now that enables them to say, oh, I see these kind of patterns in translation among them. That's wonderful and great kind of stuff. But it's still part of a larger system that has to be scaled up to a global scale. It has to be applied to multiple languages. You've got to deal with the data behind it itself. And so what we're seeing is that economically interesting systems that have some value, just even beyond the economics, often have AI pieces to them, but there's still a lot of engineering that must take place around them. So while people may focus upon these wonderful and great things like using AI to discover melanoma, remember that you have a piece of AI that says, hey, I think this might be cancer, but it has to fit within a larger healthcare system.
So again, it takes us right back to what you were saying before. It's rising level of abstractions. It's better tooling to help the person in the loop. It's not a replacement for the developer. It's not a replacement for the way we think of software today.
There will continue to be people who need to be skilled in AI. That's great. But remember, we used to have and still do have a whole set of people who are database experts, who are DevOps people. And so think of it as another bag of tools, another role to play, another skill in the larger systems building activity. This is interesting because in the last several months, people have come up to me and said, Grady, I see all this stuff happening in AI. What should I do? Should I go off and, try to learn these kinds of things? And my answer is, well, yes, you need to become familiar with it. But remember, there are literally tens of thousands of people around the world who are doing exactly that. Look in China in particular, where they're educating literal tens of thousands of people. So ask yourself, what can I do differently? And the answer I give the people then is to say, well, it's important if that's your passion, please go down that path. But remember also, you have tremendous skills through your experience and knowledge of building systems. So go think about what would it mean then to apply those skills that now have AI components. That's where I think the real fun's going to be.
Makes total sense. So are there other implications that we might need to think about, things like ethics, when we talk about with the rise of AI?
There absolutely are. Whenever you have systems that impact individuals, organizations, societies, nations, then those questions do become important. I remember it was probably 20 years ago, I started on this path of ethics is important. And I remember doing an interview. And I began down that path, and the guy stopped and said, well, wait a minute, why would any software developer ever care about ethics? And I was like, oh my gosh, dude, you just don't understand what's coming down here. The phrase I use, and it's a little bit of hyperbole, but it gets people thinking, is that every line of code has a moral and ethical implication. If you are one of the developers at a certain car company from Germany that makes very bug-like cars, and I won't mention their name, you may recall that they were righteously and rightfully cited for saying, hey, we're going to build code that actually cheats on the emission tests. So here you've got a non-AI case where a developer somewhere in the world had to write a line of code saying, I'm going to cheat on this emissions test. Code has implications. When I start moving to things like AI, it becomes a little bit scary because now we're dealing with systems that are trying to move us in the direction of human intelligence, that are reasoning and learning. And so we ask the question, how do we impose our ethics upon these systems? One of the things that's very clear, and I think it's wonderful that this is now sort of known in the community, is that there are clear biases that come from data in our AI systems. A lot of this comes from just the way we select our models. Like it or not, most of the AI developers in the world are young white men from the US. And that, in a sense, has a number of implicit biases to it that I think people recognize. The early test sets for facial recognition were mostly white people. And so they horribly failed whenever they were tried against people of color. So once those things happen and you start applying them to real world cases, like for arresting people, for identifying them as potential criminals, then all of a sudden that code, which looked very benign at first, has some very, very personal kinds of implications. For that reason, I'm delighted to see organizations such as the Partnership for AI, OpenAI, there are about half a dozen or so of them that are focused upon how does one bring ethical learning and reasoning to our AI systems. So the good news is that it at least is now in the public psyche, and certainly among AI developers, it's recognized this is a real issue. How do we solve those problems? Boy, there are smarter people than me that are going to have to tackle that one.
All right, so lots of developers out here listening to this. Some are using artificial intelligence, machine learning today, some are not. What do you recommend for people that are building systems on how to position their code bases for an AI future?
Great question. Well, the good news is that the systems engineering things that we know and love in building non-AI systems are going to apply to AI systems as well. I'll give you a great example. One of the things we know and love from test first, test-driven development, is it having a very explicit set of tests against which you can do continuous integration and regularly and automatedly test against it. That's really important. Well, that's exactly what we did in Watson, and that's exactly what the AlphaGo folks did. If you look at what Ferrucci and crew did for IBM Jeopardy, there was a test base, a set of all the answers and questions to every public Jeopardy game. And so the team was able to build a set of tools that, even though it was an AI system, they could integrate during the day, run a set of regression tests overnight, wake up the next morning, and they'd see how effective they were in running against all those questions. And so literally, you could follow this path to say, am I getting better? Am I getting closer to human level intelligence or not? The AlphaGo folks have a very similar kind of thing. The lesson here is that traditional techniques for systems engineering, for testing, configuration management, they still apply. That's the good news. And so, in a way, those software developers out there who are listening, you have things you can teach your AI colleagues. At the same time, you can learn from them. And I think it's going to come together in really a renaissance of what software engineering is. We're beginning to see how AI impacts us, how we impact it. So this is a really wonderful and vibrant time for the community.
So let's talk a bit about test cases in particular. A lot of folks on this call have written rules engines, and when you write rules engines, the test cases can be just huge to be able to cover all the different spaces and branches that are possible with a rules engine. When it comes to a neural network, that space gets even larger. It gets huge. It's obviously one of the cases that a neural network has done really well is when rules get so large, a neural network can take over and kind of help you on that path. What is the implication for writing test cases and new strategies for writing test cases when you're talking about something like a neural network?
Great question. Well, there's an overall process issue, which is this. The early days of the deep learning systems we'd see were mostly learn and forget systems. You'd teach them and you'd deploy them and you'd walk away. But one of the things that becomes important is that we do continuous learning and continuous testing so that they actually change over time. This has some interesting DevOps implications because it means that not only are you continuing to monitor this system, but you're also changing some of those systems. You're actually teaching them along the way. I don't know exactly how we integrate that in the life cycle, but that's one of the directions that's certainly going to take place. And in that process, one discovers edge cases and use cases that you simply could not have a priori known. So there's going to have to be, for AI systems that matter, this kind of growth of the test community, the DevOps community, the AI builders working together. In a sense, we're now building, in a way, living, breathing, organic pieces of software that we must keep alive.
Yeah, it's the feedback loop, right? It's a continual process. Train, score, keep going.
Yeah, exactly.
What about other techniques that software developers in code bases can do? I know you talked about like crisp abstractions that you should be focused on. What are some things that we should be really thinking about in our code bases?
Great question. Well, the phrase I often use is that in many ways, software development is kind of simple. It's all the details. You want to focus on crisp abstractions, simplicity, good separation of concerns, balanced distribution of responsibilities. What that means is it's just basic systems practices. You want to build systems that have lots of well-defined parts that are reasonably loosely coupled. And the same is true with our AI systems, that we're beginning to see AIs that are getting more and more complex. So the ideas of cohesion and coupling and modularity, we now begin to start applying to our AI systems themselves. Where does an AI fit within the container world? What's the best way to map an AI process to a Docker container? We don't quite have enough experience there yet, but my guess is that the configuration management and the way we break apart our systems today are going to be applied to the AI world as well. The other thing that probably takes place that hasn't happened yet is configuration management of data sets becomes important. So notice the direction I'm talking about here. It's more applying systems engineering to AI kinds of things as opposed to the AI stuff radically influencing systems engineering. We've been engineering systems for decades, a lot longer than we've been building AI systems. So I think that direction makes sense.
Any final thoughts before we wrap?
This is an exciting time to be a developer. There is so much changing and happening right now. It's a very vibrant time. I remember in the 80s and 90s when we were seeing the changes from algorithmic languages to object-oriented languages. I'm beginning to see the same kind of excitement and vibrancy now because we have these new, very powerful components with which we can build systems that matter. And so that's wonderful. It's an exciting time to be a developer.
Well, Grady, as I mentioned at the very beginning of the podcast, you personally have influenced me, my career, my students over the years. So on behalf of them, on behalf of myself, thank you for all the work that you've done over the years.
My pleasure. And hey, I'm not done yet.
Absolutely. I look forward to the new work to come.
Thanks very much.